Question says that let fx equal to x to the power 4 plus px cube plus qx plus 5, where p and q are constants. The remainder when fx is divided by x plus 1 is 7, and the remainder when fx is divided by x minus 2 is 1. We need to find the value of p and q. This is a straightforward question of remainder theorem, and what remainder theorem says that, like, we will be substituting x plus 1 equals 0, like we will be finding its value, whatever be the value we are getting, we will plug back that into the function. The thing will be more clear when I will write it. So first factor is, the first thing given us to us x plus 1. Let me equate it to 0. What I am getting? I am getting x equals minus 1. When I will plug this value of x equal to minus 1 in this equation, I will be getting f of minus 1 equals minus 1 to the power 4 plus p times minus 1 whole cube plus q times minus 1 plus 5. Now, the value of f at minus 1 is 7. This is what the remainder theorem is. 7 equals, now minus 1 to the power 4 will give us 1, minus 1 to the power 3 will give minus 1, so this will become negative of p, then negative of q plus 5, which can be further simplified if we wish. Let me simplify it over here. So that will be 5 plus 1, 6. So 7 equals 6 minus p minus q. I will be taking both of them to the left hand side. So here I will get p plus q. What I have done? I have taken this p, this q to the left hand side and this 7 to the right hand side. So I will be getting 6 minus 7 over here. So from here I can say that p plus q equals minus 1. This is my first equation. Let me name it as first equation. Now I will be working with the second thing. Second thing is given as x minus 2. For x minus 2, the remainder comes out to be 1. So let us equate it to 0. When I equate x minus 2 equals 0, I get x equal to 2. Now what I will be doing? I will be doing the same thing what we have done over here. I will plug this 2 in this given equation. So this will give me f of 2 equals, wherever I am looking at x, I will be plugging x equals to 2. So 2 to the power 4 plus p 2 cube plus q times 2 plus 5. On simplification, the value of f of 2 should be 1 because the remainder is coming out to be 1. So here it is, 2 to the power 4 is 16, 2 cube is 8, so 8p, 2q plus 5. So let us keep these two values on one side and the numerical values on the another side. So that will give me, if I take 5 and 16 to the left hand side, so I will be getting 1 minus 5 minus 16 equals 8p plus 2q. Let us simplify this. So minus 21 plus 1, that will give minus 20 equals 8p plus 2q. Now this is our second equation. We can simplify it further. There is one thing, we can divide each and every term by 2. Okay, so if we divide it by 2, the equation remains the same in the sense that there is no variation. So minus 10 equals 4p plus q. Let us name this as our equation number 2. Now what we will be doing? We will be subtracting these two equations. So let us subtract these two equations. So my first equation is p plus q equals minus 1, and my second equation is 4p plus q equals minus 10. When I subtract them, the signs will be changed. This q will be cancelled out, q minus q. Minus 4p plus p will give me minus 3p equal to 10 minus 1 is nothing but 9. So from here what I can say, dividing minus 3 on both the sides, I will be getting P equals 9 over minus 3, and that will give me P equals minus 3. Now I will plug this equation of P in either of the two equations, that is in first or in second. Let me substitute the value of P in the first equation. So I will be getting minus 3 plus Q equals minus 1. Now I take this minus 3 to the right hand side, so I will be getting Q equals minus 1 plus 3, that gives me Q equals 2. So I can say that P equals minus 3 and Q equals 2 are the required answer.